we're talking about virtual testing for IoT software, but let's back up a bit. Let's look at the situation for some of the traditional challenges of IoT software testing. Now, first and foremost of these is a dependency on devices. So testing an IoT solution tends to depend on the availability of IoT devices. That makes iterating hardware designs, I mean, it takes time to do that. It's hard to consider hardware variations, enhancements in performance or different options for sensors, etc., or different ways of configuring the device or even the circuit boards within the device and the connectivity within the device. It's really hard just to change these things, instantiate them into a physical device, and then test it again. So that takes time. And this just presents friction for optimization of hardware and software combinations, particularly looking at different versions, and the lead times associated with this can be long. So really, you want to start testing a lot earlier. And often development and test tends to start in the cloud, and it tends to start before the device is available. As I mentioned, it tends to take quite a while for the device to be available. So people tend to start thinking about what the application does in the cloud. But the functionality of applications is increasingly distributed across cloud environments, edge environments, or on-device domains. So it's really hard to actually do that full testing in a cloud when you haven't got the devices aren't ready. So again, that kind of anything other than basic and initial testing in the cloud is hard without the device. And something like load testing is basically impossible before field deployments. I mean, testing 10 million smart meters or something like that is very difficult, if not impossible, in a lab. So really, this is a significant challenge. And there's another dimension, which is just testing the full range of functionality and interfaces with the device. So you can only go so far in testing without the physical devices. And then, of course, there's a communications layer to factor in there. So particularly if the device is using cellular connectivity, because those environments can vary country to country, and even within country, they can vary by operators. They can vary across different generations of communication technology that the same operator is offering. And bench testing just doesn't adequately reflect these subtle variations in field environments. And there are numerous, I mean, I'm going to call them edge cases, and they might be edge cases from a development perspective, but they can be very normal scenarios in a network and operating environment. So dealing with things like lag, and not just lag, but the jitter or the variance of that lag tends to be a much more critical thing than the lag itself. That could be classed as an edge case, but it's part of day-to-day running, frankly, of a device in the field. And looking at scenarios for how that might vary, looking at roaming between different networks or fallback onto different generations, it's quite hard to consider all of that. And of course, overall, this traditional approach is limited to bench testing, not field testing, because you don't want to do full deployment and then test. You might do some proofs of concept, but it takes a lot of development to get to that point, and even then testing for scale is difficult. And you can't test the full functionality in all contexts. So that's some of the traditional challenges IoT software testing.